Myself Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Dundigal, Hyderabad, India. Today we are going to study in this session what is path of contact, arc of contact and contact ratio. So path of contact is the length of line of action where engagement and disengagement of teeth takes place. Now it is the locus of the path of contact of two mating gears from the beginning of engagement to the end of engagement is known as contact length or path of contact. In this figure we can see the path of contact, that is the total, is CD. It is one of the driver pulley. This is the driver and it is follower. This is the driver and it is follower. Here the total length of contact length is CD. The CD is again divided into two parts, that is CP plus PD. The CP is known as path of approach and whereas PD is known as path of recess. Recess means a disengagement. Now there is a point P between CP and PD. There is a point P. That point P is known as pitch point. Pitch point is the point where the mating of two pitch circles of driver and follower wheels takes place. This is the point. Now this is the path of approach, means it is a portion of path of contact between the teeth from the point of engagement to the pitch point, that is CP, that is path of approach. And path of recess is from the distance from pitch point to the point of end of engagement or point of disengagement is known as the path of recess. The sum of approach and recess is known as contact. The path of approach plus path of recess equal to path of contact or contact length. And arc of contact. The arc of contact is the pitch circle from the point of engagement to the end of engagement. So there are two types of arc of contacts. The arc of contact for the driver and the arc of contact for the follower. The arc of contact for the driver is EPF, and arc of contact for the follower is, that is APB and EPF. APB related to follower, APB related to follower. APB is arc of contact related to follower. Arc of contact, that is EPF, related to driver. So this P is the pitch point. So again, arc of contact, again the sum of, that is number one, arc of recess, another one is arc of approach. If you consider the driver pulley, arc of approach is EP and PF is the arc of recess, and arc of approach for the follower is AP and PB is the arc of recess. The sum of approach and recess is known as contact. If it is arc of approach plus arc of recess equal to arc of contact, and for the driver and the driven pulley. Now what is arc of contact? Another definition mathematically, arc of contact equal to path of contact over cos phi. This where is the phi is the pressure angle. What is path of contact? Here in this case, path of contact is the sum of path of approach plus path of recess. Path of approach so what is the path of approach? Path of approach takes place on a driver that equal to under square root of RA square minus R square cos square phi minus R sin phi. Path of recess, PATH. Path of recess takes place on on follower, that is small letters, small RA square minus R square cos square phi minus R sin phi. The sum of these two formulae is the formula for the path of contact. So path of contact is the sum of again path of approach plus path of recess. Now another term is called angle of action. This angle of action is the sum of angle of approach plus sum of angle of approach and angle of recess. So angle of approach is denoted by alpha and angle of recess is denoted by beta. That total sum is known as angle of action. So what is the definition of angle of action? Delta is the angle turned by the gear from the point or beginning of engagement to the end of engagement of a pair of teeth. Or simple in one word, one sentence definition is that the angle turned by the arcs of contact of respective gear wheels is known as angle of action. So the angle of approach is denoted by letter alpha, and angle of recess is denoted by beta. The sum of alpha and beta is known as angle of action delta. So the angle will have this angle of action is different from driver to follower. The angle of action is different values. It varies from driver wheel to follower wheel. And contact ratio, the term contact ratio, that contact ratio equal to arc of contact by cos phi by circular pitch PC, where circular pitch PC equal to pi d by t, pi times d by t, where d is the pitch circle diameter and capital T is the number of teeth. So this is a circular pitch. Now what is the arc of contact again? This arc of contact in terms of it is path of contact, that is path of contact by cos phi. Again, what is path of contact? Path of contact equal to path of approach plus path of recess. Now let us solve. We have to start problem to solve and how to apply this path of contact, arc of contact and contact ratio. Each of two gears in a mesh has 48 teeth and a module of 8 millimeters. The teeth are of 20 degrees involute profile. The arc of contact is 2.25 times the circular pitch. Arc of contact equal to 2.25 times circular pitch. Determine the addendum. What is the addendum? That is Ra minus R. So here they have given here the data was given here the angle, pressure angle, that is 20 degrees, and here both wheels are same, so small t equal to capital T equal to 48. That means gear ratio is equal to 1, and m equal to module m equal to 8 millimeters. Now R equal to mt by 2, that is 8 into what is the T, 48 by 2, that is 192 millimeters, and both are same, so the addendum radius equal to addendum radius of the gear equal to addendum radius of pinion, RA equal to RA, capital letters R, A equal to small letter RA. Now arc of contact, that is 2.25 times circular pitch. What is the circular pitch? That is 2.25 times P is equal to pi times m. That is 2.25 times. What is the pi m? Pi times m equal to 8. What is the arc of contact? That arc of contact equal to path of contact by cos phi. So what is the path of contact here? This is the arc of contact value. Then path of contact, that is POC equal to 2.25 times pi into 8 times cos 20 degrees. That value is 53.14 millimeter. What is path of contact? Substitute the formula, that is RA square minus R square cos square phi minus R sin phi plus, that is approach plus recess. Finally, here RA equal to, because both wheels are same, and capital R equal to small r, capital RA equal to small RA. Now it becomes 2 times. Now 2 times RA square minus, what is the R? This R obtained here 192 millimeters, cos is 20, phi is 20 degrees. Now minus 192 sin phi 20. Finally RA is obtained as 202.6 millimeters. Now the addendum formula, this is RA minus R. Addendum. That RA minus R, RA is 202.6 minus R. What is that R value here? Radius of the pitch circle 192. Then it becomes 10.6 millimeter. And how it is obtained, this R, that mt by 2. How it is obtained here? Capital R equal to mt by 2. That is m into capital T by 2. 2 multiplied here, 2 times R. M into capital T. What is 2 times R? That is the diameter D. M into T. D by T, that equal to M. So M equal to D by T, module equal to ratio of pitch circle diameter to the number of teeth, D by T. Now here we want capital R. That's why what you have done? Convert D 2 times R by T. Now R equal to MT by 2. Whatever small r equal to m into small t by 2. Number of teeth of pinion by 2. That is the radius of pitch circle radius of pinion. Pitch circle radius of gear, that is r equal to mt by 2. Here both are equal. Capital R equal to small r. That's why we considered m into capital T by 2. Suppose if we data was given here it is. Now I am considering the same problem, but data I am changing. And how to solve? The phi equal to 20 degree and capital T equal to 48 millimeter, 48 teeth. Small t equal to 24 number of teeth on the pinion. And module m equal to 8 millimeters. Then, for the same condition that arc of contact, the arc of contact is equal to same thing 2.25 times circular pitch. Now one more value we need, that is RA, addendum circle radius of pinion, that is capital R plus R equal to M2 by 2. Yes, we can obtain. Now it is RA. Now if you want to solve for different teeth, then capital R and small r, how it happens, how to calculate for small r. Capital R equal to m into capital T by 2 and small r equal to m into small t by 2. What is the capital R here? That is m, 8 into capital T, 48 by 2. Small r equal to 8 into 24 by 2. That is how much? I think it is 96 millimeter. Capital R and small r. Then how it comes? RA we need. Then only. Then how to find out? Suppose if they have given that RA is RA equal to, yes, we can find out RA. That RA equal to addendum, radius of the addendum circle. R plus module. Suppose if it is the length, the R plus 1 time 1 module, that is the addendum radius. What is R equal to? Just know that is 96 plus 1 module, 8. 96 plus 8, 104 millimeters. From this data we can find out path of contact and arc of contact also. And also contact ratio we can calculate from this data. So in this manner here I want to mention that I want to show you how to calculate this R, capital R and small r. When capital R is that much, whatever small r is 104, capital R equal to capital R plus 1 module. Capital R, what is the capital R here? 192 plus 8, that is 200. RA we know R, capital RA and R, both wheel driver and follower wheels are known. And then we can substitute in this. Then it doesn't come 2 times RA square because these wheels are not equal. Then substitute over here. Then we can see, we can study the, we can see the contact length. Then, okay, arc of contact given, then we can validate it, whether it is arc of contact is same or not by using this data. The next problem, if we consider 2 involute gears are in mesh have 20-degree pressure angle. The gear ratio, that is capital G equal to 3, and the number of teeth on pinion is 24. The teeth have a module of 6 millimeter. The pitch line velocity is, velocity of pitch line velocity is 1.5 meter per second, and the addendum equal to 1 module. Addendum equal to 1 module. Determine the angle of action of the pinion. Determine the angle of action of the pinion. Angle of action of the pinion. That means the angle turned by the pinion when one pair of teeth is in the mesh, and the maximum velocity of sliding. Maximum velocity of sliding. There are 2 objectives are here to be solved based on the given data. Okay, how to start? This addendum given condition and the pitch line velocity also given, that is pitch line velocity is 1.5 meters per second. Okay, this is 1.5 meter per second. And how to start? We know that phi equal to 20 degrees, small t 24, module 6 millimeters. Based on the gear ratio, we can calculate number of teeth on the gear wheel, on the larger wheel. The gear ratio is 3, that is 3 equal to capital T by small t. That small t is 24, that is capital T means 3 times 24, that is 72. Now, next we need R radius of addendum radius of the wheel and the addendum radius of the pinion and pitch circle radius of the wheel and pitch circle radius of the pinion. How to calculate? Now we know that R equal to m into T by 2. What is that? M 8 here m is how much? 6 module, that is 6 times small t, number of teeth, 24 by 2, that is 72. And capital R, radius of the pitch circle radius of the wheel, capital T by 2, 6 into capital T. What is it? Capital T, 72 by 2. Then 3 times 72. That is 216 millimeter. After calculating R, then RA equal to small r plus m. What is small r here? 72. What is the module? 6. That is 78. Similarly, RA, addendum, radius of addendum of the gear, RA equal to 216. RA equal to capital R plus 6. That is 216 plus 6. That is 222 millimeter. We know capital, that is radius of addendum radius and pitch circle radii of both gear and pinion values are known now. After knowing, substitute in the formula of a path of contact. The path of contact formula is path of approach plus path of recess, where path of approach equal to RA square minus, up to here only, RA square minus R square cos square phi minus R sin phi, plus for path of approach, path of recess is addendum radius of, we have to consider the pinion, their dimensions, that is small letters RA square minus R square cos square phi and the square root of RA square minus R square cos square phi minus R sin phi. After substituting here over here, we can observe the value of path of contact. Path of contact equal to path of approach value 16.04 plus path of recess value 14.18. Then total sum equal to 30.22 millimeter. Now here the path of approach value is more than the path of recess value. So path of approach is larger here than path of recess length. The sum of the length of approach and recess equal to the contact length of the two teeth. Okay, now arc of contact. That arc of contact equal to path of contact by cos phi. We know the path of contact, that is 30.22 millimeters by cos phi, cos 20 degrees. Then angle of action, we have to find out, determine the angle of action of the pinion. That angle of action of the pinion, that equal to arc of contact by pitch circle radius of pinion, that is small r. That arc of contact calculated as 32.16 millimeters by pinion radius, that is pitch circle radius of the pinion, that is 72. 32.16 by 72, we can observe it, that value as 0.4467 radians. Convert into degrees, 0.4467 into 185 pi, that is 20.59 degrees. That is first objective. Suppose if determine the angle of action of the wheel, of the gear, angle of action of the gear, then the formula equal to arc of contact by capital letter pitch circle radius of gear you have to consider. Now that was the first objective, angle of action completed. The second objective is velocity of sliding, maximum velocity of the sliding. The velocity of sliding, maximum velocity of sliding equal to angular velocity of the pinion plus angular velocity of the gear times path of approach. Now here angular velocity of the pinion, that is v by omega by v by small r, plus angular velocity of the gear, that is linear velocity by capital R, that is pitch circle radius of gear. We know the V given here, 1.5 meters per second convert into millimeters, that is 1500 millimeter per second. Why we have to convert? To maintain the dimensional homogeneity, because here the radius all are in millimeters. So we convert these meters into millimeters, that is 1 meter equal to 1000 millimeter. 1 meter equal to 1000 millimeters. So multiply this 1.5 meters, that means 1.5 times 1000, 1500 millimeters per second. The substitute over here, that is 1500 by 72 plus 1500 by capital R 216 times the path of approach. The path of approach value is 16.04. Substitute that value in this. Then that is the velocity of sliding. The velocity, that is the maximum velocity of the sliding. Then we can see that 445.6 millimeters per second. So that convert into meters, that is 0.445 meter per second. 56. So meter per second. This is the manner one has to calculate the velocity of sliding. Suppose if the same problem they have given by changing the data, in the place of the pitch lane velocity is 1.5 meter per second, and here the asked here it is maximum angle of action of the pinion. Suppose if it is asked angle of action of the gear, then the formula becomes arc of contact by capital R. This capital R is the pitch circle radius of gear. That arc of contact, that is 32.16 for the pitch circle radius of the gear. That capital R, we calculated here, it is capital R equal to 216 millimeters. 216. So the value becomes, if you that is convert into degrees, then it becomes a lower value in comparison to the angle of action on the pinion. Why it is? Because the lower angle value comes in the case of arca gear, it is lower value, angle of action is lower than the value of angle of action of the pinion. Why it is of the pinion? Because the diameter of the pinion is, it is smaller. The radius of the pitch circle radius of the pinion is smaller in comparison to the pitch circle radius of gear. That's why the angle of action on the pinion is more than the angle of action on the gear. This is the problem. This is the model number 2. Here it is. So we solve the problem of this. What is the angle of action of the pinion and the angle of action of the gear, even though object was given only angle of action of the pinion and velocity of sliding, maximum velocity of sliding. So if the two wheels are equal, so let us interpret some of the things. Suppose if two gear and pinion, the number of teeth on the gear equal to the number of teeth on the pinion. That means capital R equal to smaller, both having same pitch circle radius and also addendum circles also same. Then the path of contact, equal to path of approach equal to path of recess. That means 2 times path of approach or 2 times path of recess. That means the meaning from this here, path of approach is equal to path of recess. When path of approach equal to path of recess, the pitch circle radius of or the number of teeth is equal for both the wheels, or the pitch circle radius is equal for both the wheels, or the addendum circle radius is equal for both the wheels when they are on external meshing. Then the wheels having, then the path of contact equal to 2 times path of approach or 2 times path of recess, or path of approach equal to path of recess. So, but if it is not equal, when t is not equal to t, then what will happen? Capital R equal to small r, capital RA is not equal to small ra. At that time, path of contact equal to path of approach plus path of recess. And one more thing, path of approach is not equal to path of recess. Path of approach is not equal to path of recess. Thus, we can find out, we have to interpret the different different formulae. We can explore or we can extract different formulae based on the given data and conditions. There are two models we have studied in this session. Number one is, what is the addendum, calculation of the addendum, and second model, calculation of the angle of action of the pinion and angle of action of the gear and maximum sliding velocity. Maximum sliding velocity we have calculated in this session. And also we have studied what is path of contact, what is arc of contact, and contact ratio concepts. So the path of contact and the path of approach is divided, is separated by one point. That point is known as a pitch point. So what is a pitch point again? It is a pitch point is the contact of two pitch circles. The pitch circle of a gear and the pitch circle of the pinion is intersect at a common point. That point is known as the pitch point. And what is the angle of action? And what is the pressure angle? Pressure angle is the angle between the normal to the pitch point, normal to the contact point, and the line of action. So then it is known as pressure angle. If the pressure angle is high, what will happen? There will be a chance of damage of the gears takes place. That means pressure on the wheels becomes high. So the standard pressure angles are, the standard pressure angle is 20 degrees, 25 degrees, and also 14.5 degree, 14.5 degrees. So these are the optimum pressure angles. So if the pressure angle increases, what will happen? If the pressure angle decreases, so pressure is so, I don't want to apply more pressure, reduce the pressure angle to 1 degree or 2 degree. Then what will happen? So there will be no torque transmission takes place. So the optimum pressure angles or the standard pressure angles are 20 degrees, 25 degrees, 14.5 degrees. But now the maximum gears are designed with the pressure angle of 20 degrees and 25 degrees, but not 14.5 degrees. 14.5 degrees are obsolete now. So these are the concepts and fundamentals about arc of contact, contact ratio, and path of contact. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.